Till now, we have discussed about the acceleration due to gravity variation due to the height of the object from the Earth's surface. Obviously, there is a decrease in acceleration due to gravity with respect to the variation of height. So let us now discuss when the object is below the Earth's surface. That means the object is somewhere inside the Earth. Okay, so let us discuss or assume that the object is at any hole d depth under the ground. There is a hole on the surface of depth d and the object is inside that hole. Okay, so from the surface to the object it is the distance is d. So we have drawn this picture in a page. Let us see. This is the diagram drawn in the page. This boundary is the Earth's surface. The object of mass m is at a depth d from the Earth's surface, and the distance between the center of the Earth and the mass is r minus d. That means r is the radius of the Earth. At this position we have to minus d. So the separation between center of Earth and the mass is r minus d. Here we have assumed that the density of the Earth is uniform. So it is a homogeneous sphere of uniform density rho. So on the surface of the Earth, acceleration due to gravity is capital G capital M by r square, where G is the gravitational constant, M is the mass of Earth, r is the radius of Earth. So we can write mass of the object in terms of density of the material of the Earth. So mass can be written as 4 by 3 pi r cube rho. So the expression of small g, acceleration due to gravity, is 4 pi by 3 g capital R rho. Let the object is at depth d. So there is a decrease in radius of the Earth by d. So at depth d, acceleration due to gravity expression will be g m prime by r minus d whole square. So r is substituted by r minus d separation, and m prime is the mass of the inner solid sphere. Inner solid sphere means this one. This is the inner sphere. So mass of this inner sphere, we have assumed it as m prime. So m prime can be written as, again, in this form, 4 by 3 pi rho r minus d cube. Here value of r is r minus d cube. So the acceleration due to gravity at depth d is expressed in this form. So the final expression will be acceleration due to gravity at depth d is 4 by 3 pi g rho r minus d. So we have numbered this equation as 1 and this equation as 2. This equation is on the surface of the Earth, and this expression of acceleration due to gravity at depth d. So dividing equation 2 by equation 1, we have this expression. On dividing equation 2 by equation 1, we have gd by g is equal to 1 minus d, where depth by a radius. So this is the expression. Final expression is like this. Acceleration due to gravity at depth d is given by g 1 minus d by r. So acceleration due to gravity decreases when depth increases. That means gradually value of acceleration due to gravity decreases when depth increases, or we can say when object moves towards the center of the Earth. So at the center of the Earth, separation d is equal to radius of the Earth, and when we put here in place of dr, then we will get this bracketed term equals 0. Therefore, acceleration due to gravity at the center of the earth will be 0. And at the center of the earth, weight of the body at the center is 0. Since acceleration is 0, then 0 multiplied by mass of any object give us 0 weight. So at the center of the earth, weight of the object is 0 since acceleration due to gravity is 0. So the fractional change in g or fractional change in acceleration due to gravity can be written as the ratio depth by radius of the earth. Similarly, when we multiply this value with by 100, then we will get the percentage decrease in the value of g. This is d by r multiplied by 100. We have seen that the value of acceleration due to gravity at any height from the earth's surface or at any depth d below the earth's surface decreases in comparison to the object on the earth's surface. So due to the decrease in acceleration due to gravity at any height h or at any depth d, obviously there is a loss of weight. So when we reach the center of the earth, the value of acceleration due to gravity will be 0, due to which weight of the object decreases to 0. And similarly, when height increases from the earth's surface, the value of g also decreases. Therefore, there is a decrease in the weight of the object. So from this concept, we can find out the loss in weight due to the change in height of the object from the earth's surface. Let us see. So this is the expression of loss of weight for height very small compared to radius of the earth. So variation of z is expressed in this form, multiplying both side of the equation by mass of the object small m, and on simplification we have mg weight on the surface of the earth minus mg at height h. So it is the weight of the object at height h is equal to twice mgh. This difference is the loss in weight. So loss in weight due to height h of the object is twice mgh by r. So if we are asked to find out the loss in weight, then we can put this formula directly if we know value of h and m. Also, we can find out the value of z at what height and depth the change in acceleration due to gravity or new acceleration due to gravity are equal. So, the relation can be obtained by equating the value of acceleration due to gravity at height h and at depth d. So, we can solve this problem as, let us assume that at height h and at depth d, the acceleration due to gravity will be equal. So let us find out the relation between d and h at which both the acceleration due to gravity value are equal. So acceleration due to gravity at height h is expressed as like this, and acceleration due to gravity at depth d from the earth's surface is this. So on simplification, we have this expression twice h by r equal d by r. So d, depth of the object from the earth surface, is equal to twice that of the height h. That means h is the object at height h from the earth surface. So the value of z at height h is same as the value of z at depth d equal twice h. So but this relation holds good or true only if h, that means height of the object from the earth surface, is very small. For comparable height with radius of the earth r, then we cannot write this expression.